So in this question we have this 1,500 kilogram car. It is being pulled by a tow truck at an angle of 45 degrees above the horizontal with 2,000 newtons worth of force. Everybody all right with that? Okay. The most important part of this question is realizing which way the car is going. Is the car going in the direction of that force? No, it's being pulled by the tow truck. Typically, even though it's angled, the car is only actually moving horizontally. That's the thing I have to get out of this question in order to attack it properly. Okay, that way I can put friction on here in the right direction. Friction has to directly oppose the motion. The motion is horizontal behind the truck. So this is friction here. It's 500 newtons. Okay. The other forces acting on the car would be then, okay, the force of gravity acting down. There would be some normal force. Okay. Why didn't I draw normal force and gravity equal? On a level surface like a road, aren't they supposed to be equal? Right? Like if I set a book on this desk, gravity and the normal force were equal. Why are they not equal in this situation? Are there any other vertical forces? Where's the other vertical force, Ben? Yeah, it's in the winch. It's in the cable here. The cable is pulling upwards with a vertical component. It is also pulling horizontally here. All right, so the combination of this vertical force here, normal force, and gravity is what? What do those three forces add up to? Is the car moving vertically? It's being pulled behind the tow truck. Is it moving vertically? It's not. What's the net force vertically? 0. Okay, so these three forces here all add up to 0. Okay, but what is important is this force, the horizontal component of the 2,000 newtons of tension in the winch cable, right? Because that has got to go along with the force of friction. Okay, so the other thing the car tells me, or sorry, the question tells me is that we want to find the acceleration. Well, can I find the net force right now? Right? I mean, I know what the forces are. I need this horizontal force. Can I find it? Yeah, I can find it. I'm just going to use some trig there, right? So the horizontal component of that cable's force is going to be 2,000 times the cos of 45 degrees, okay, which is going to be 1,414 point something. I don't remember what. Okay. Uh, 0.21. Okay. All right, so there's a forwardly directed force of 1,414.21 newtons. There's a backward directed force of 500 newtons. That's friction. Now I can calculate the net force using the vector sum of all forces, the horizontal component plus the force of friction. All right, so that'll be 1,414.21 plus negative 500, right, will give me 914.21 newtons of forward directed net force. Everyone follow what I've done so far? All right, so now I have that much forward directed net force. Can I now find the acceleration of the car? All right, so now I go F net equals m times a. Acceleration will be 914.21 newtons divided by the mass of the car, 1,500 kilograms, and that will give me 0.609 meters per second squared in a forward direction. Okay. All right, is that fairly vector intensive? I mean, there's vectors in there, but really I only had to do one trig calculation. Right? I did one trig calculation so I could get a missing force. Then it was the same as every other question we've done to do with Newton's second law. Sum of all forces and m times a. Right? Are we seeing the common thread between all of the questions we've done so far? Okay? Always sum of all forces okay, and F equals M times A, right? How we get all those forces is usually the tricky part. What do I have to calculate? What forces are important, okay? So on that worksheet that says force is a vector quantity, there's quite a few questions like this one where they're quite intuitive, okay? There's not a lot of math, there's a little bit of trig, okay? And you guys won't have any trouble with them, okay, mathematically speaking. You will probably take a little bit of time to figure them out to get to that. Okay, and then there's the inclined plane worksheet that we started. Okay, I think we did one question off of that yesterday or something like that. Okay, I want to work on those two for a little while. Okay, then we'll take a little break and I'll talk about tomorrow's lab, and then we'll kind of finish up working on some more vector stuff because tomorrow's lab will be very much vector and system related. Okay, so in your workbook package, okay, you've got the forces of vector quantity worksheet. Okay, so that's the one I'll put up on the board. You'll have to call up the inclined plane one. I'd like you to go back and forth on those. Okay, do one inclined plane, one forces of vector quantity question. All right, I am expecting that there will be a number of these that we'll need to go through. That's fine. Don't be shy about asking. Okay, this morning I think I went through in my morning class probably 8 different problems. Okay, so if you don't get it, you're not the only one. Okay, don't be afraid to ask, and we'll go over them if you're having trouble. Okay, if you want some help individually, just put up your hand, and I'll come around and help you out that way as well. All right, so in question number 4, okay, we have this fish. So that's about as best. That's my best drawing ever. Okay, and it's unhappy because it's hooked. Okay, so we have a force here, and it's unknown. It's what we're asked to find. All we know is that it's 45 degrees above the horizontal. Okay, in the question, we're told the fish is moving horizontally, and that's an important piece of information because that tells us which way to make friction. Friction has to be straight back, and it's 80 newtons. Okay, it's moving at a constant speed horizontally this way. So, since I have a backwards force of 80 newtons, how big is the horizontal component of the tension in the line? It's moving at a constant speed. What's the net force? 0. Okay, that's in all directions, up and down as well as horizontally. But I know I have an 80 Newton force directly backwards. That means I have to have an 80 Newton force directly forwards. That is the horizontal component of the tension in the line. The line is angled. But if I've got 80 newtons back and it's moving at a constant velocity in a horizontal direction, I have to have the same amount of force forwards. Okay, so the kind of intuitive leaps for this question are net force was 0, and then that this 80 and this 80 have to be equal. All right, then we can find the tension in the line using trig. I have the adjacent side to this 45-degree angle, so I should be able to find the tension in the line. The tension in the line is the hypotenuse, so that'll mean 80 newtons divided by the cos of 45, and that will give me 113 newtons. I could put the 45 degrees from horizontal, but remember, again, it's a tension. Tension doesn't really have direction. It pulls in 2 directions. From the fish's point of view, yeah, it's 45 degrees from the horizontal, okay? But in actual fact, tension in the line is omnidirectional or unidirectional. Because the fish is moving horizontally. There would be other forces that would offset the vertical component. So there would be gravitational force acting downwards on the fish, the vertical component of the tension, as well as any buoyant force that could be present there for the fish. Or maybe the fish is trying to dive, but the tension is not allowing it to do so. So there could be an exerted or applied force downwards from the fish. We don't know that, but in the end, it doesn't matter. We're told it's moving horizontally for exactly that reason, so that we don't start considering other forces, just the horizontal ones. Okay? And the other one's giving us trouble. Okay, so are we going back and forth between the inclined planes and vectors? Okay, make sure we're doing that so that we don't end up having to do a whole bunch of inclined planes all at once. Okay, all right, keep going. Seems like we're doing all right. All right, so number 6 is just truly a vector addition question, vector component addition. Okay, we first draw our free body diagram showing the big snowball. Okay, we know that the mass of the snowball is 50 kilograms, so we write that on there. One kid is pushing it this direction with 130 newtons worth of force, and that is directed 15 degrees west of north. All right, so that would be our first force, and the other kid is pushing due west with 110 newtons. All right, so I draw the free body diagram, but other than identifying the forces, it's no good to me after that. All I can see from this is that generally the snowball is going to go in a northwesterly direction. Everybody okay with that? Right. In order to find the acceleration, I need to know the net force, right? Which means I can't use m times a because I don't have the acceleration. What's the other way to get net force? It's the vector sum of all forces. All right, so I got to get the vector sum of these forces. That means I've got to draw a vector diagram. So I'll have my 130 newtons. Okay, it's got an x and a y component. It's 15 degrees west of north. Then I'll have my 110 newtons due west, and then I'll have my resultant, which is the vector sum of all forces, and is thus F net. Okay, it'll have a theta, a y component, an x component. Okay, I solve for all the x's and all the y's, right, and I get the end result here. Okay, so you know, solving for black x and black y, we would have the sine, sorry, x would equal the sine of 15 times 130. Y would be the cos of 15 times 130. Okay, so 33.65 newtons. Okay, and then cos of 15 times 130, right, is 125.57 newtons. Okay, so now I know these. This is 125.57. This one is 33.65. Now I can find blue x. Okay, so blue x will be 143.65 because it's this plus that, right? And then blue y will just be 125.57. Do my Pythagorean theorem, my trig, I've got my net force, okay? And then I can just divide by mass to get the acceleration.
Can you question 6 on the other?
On the inclined plane?
Yeah.
Okay. This one? Okay, which one are you looking at?
Oh, sorry, question 5.
5, okay. Okay, soapbox derby racer. Okay, so for our soapbox derby racer question, okay, listening please, we've got an inclined plane, a hill essentially, okay, and we know that we're looking for the angle on this. So it's still going to be the same steps. I'm just going to do them in a different order, okay, because I don't have the angle to start off with. All right, what I do know is that the racer is 65 kilograms. I know that there is a frictional force, which has to be up the hill since they're accelerating down the hill, okay, of 25 newtons, and that'll be the force of friction. What's pulling them down the hill? It's not gravity, it's the component of gravity that's parallel. We call it F parallel, right? All right, so F parallel is going down the hill. The most important part of this question is making sure I have this internal triangle. The hypotenuse is always gravity. This side is always normal force, which I won't need for this question or very many questions for that matter. Okay? And then this side here is F parallel, and this angle is the same as the angle of the hill. All right, so right now I can figure out the force of gravity because I got mass and I know what gravity's acceleration is. Okay, so 65 times 9.81 is 637.65. All right, so I've got one side of this triangle. If I want to find that angle, I need one more side. There's no way for me to get normal force, but because I know the acceleration, which is 4.25 meters per second squared, and the mass, I can calculate the net force. With the net force, can I calculate F parallel? Yes. And once I have F parallel, I have two sides of this triangle. And now I can figure out the angle using trigonometry. Okay, so it's almost completely backwards from the way we've done the other ones, but it's still the same steps, just shuffled. Okay, so we would find F net, okay, by going 65 times 4.25. Okay, so 276.25 newtons. Okay, so the other way to get net force is the vector sum of all forces, so that would be F parallel plus the force of friction. So I can calculate F parallel by going F net minus the force of friction, right? So that'll be 276.25 minus negative 25, right? Because it's up the hill and I'm making up the hill negative. So 301.25 newtons, okay, as my force parallel. Now that I have that, then I work backwards with trigonometry and I get the angle. Okay, so anytime you're asked to find the angle on a inclined plane question, then you're going to have to fill in this triangle as much as possible. Usually that means gravity and F parallel. Sometimes they won't give you the mass, and they'll ask you to calculate what the mass is. And again, you'll need to get a side and an angle, then find gravity, etc. On the inclined planes, number 4. Okay. All right, does that answer your question, though? Just. Yeah. Okay. Keywords. They're in bold. What are the keywords? Constant velocity. What's the net force in this question? Okay. So we're pushing this car up a 9-degree incline at a constant velocity. We're looking for the mass. So as I just said, I'll probably want to find gravity. Then I can find from the force of gravity, I can find the mass from there, right? So it's being pushed up with a force of 800 newtons. Friction is resisting with 100 newtons. What's the other force here? F parallel. Okay. How big is F parallel? 700 newtons. It has to be because the net force is 0. So I've got 800 up, I've got to have 800 down. That's the leap you have to make for this one. So now I have F parallel being 700 newtons. So if I want to find mass, then I need to find the force of gravity. Well, that means use this side, which I know is 700, and this angle, which I know is 9 degrees. Then I can find the force of gravity, divide it by 9.81. All right, so I'm going to take that 700 and find the hypotenuse. So I will go, the hypotenuse will equal the 700 newtons, the opposite side, divided by the sine of 9 degrees. All right, so we get 4,474 newtons. Now I divide that by acceleration due to gravity, and I'll have the mass. Okay, 456 kilograms. Yeah? Yeah. Okay. That's a tricky one. We haven't done one like that either, right? So it's always good to get exposure to lots of different kinds. Again, it was all the same steps, though. It's just a matter of how can Coder ask it so he can shuffle the steps in a way you haven't seen. I did. Right. But this is only this side of the triangle is only 700, right? This is only finding F parallel. It's not finding the net down. Okay? Right? This triangle will only get me F parallel. Okay? So that's why I didn't factor in the 800 there. Yeah. Okay, any other ones? This is good. Okay, asking lots of questions. Don't be afraid to do that. All right, I'm going to give you guys about a 5-minute break here. Okay, just kind of relax, stop doing some physics for about 5 minutes. Then I'm going to talk about the lab tomorrow, and then we'll work on a couple more after that. Okay, so we've got this question here talking about building the pyramids, okay, using inclined planes and not super secret alien technology. Okay, we know that the ramps are inclined at 10 degrees. We know that the stones that are used to build the pyramids are 5,000 kilograms apiece. Okay, the key words in this question: constant velocities. All right, what's the net force in this question? 0. All right, so that means whatever force they're exerting upwards is counteracted by the forces downwards. So if I'm drawing a free body diagram, I've got the force applied by the slaves up the ramp, and then I've got friction down the ramp, and what else down the ramp? Not gravity. Gravity acts straight down. What's the one that's the F parallel, right? Okay, so since it's moving at a constant velocity, F parallel plus force of friction plus force applied equals 0, right? Otherwise, they would be accelerating up or down the ramp, and they're not. All right, so from here, okay, the force they need to pull with, we're looking for the force they would need to pull with. We know that the force of friction is 800 newtons. All right, can I calculate F parallel? Okay, so I'm going to do that next. Okay, calculate F parallel. So I got FG. Okay, I got F normal, which I'm not going to need on this question, and then I've got F parallel being right here, and this angle being 10 degrees. So first I got to calculate FG. Okay, 5,000 times 9.81 should be 49,050, right? Newtons, yeah. Okay, and then I'm going to find F parallel. Since it's the opposite side, I'll go the sine of 10 degrees times 49,050 newtons. Okay, so I've got 8,517 newtons worth of F parallel. Point whatever, right? 0.44. All right, so I've got this force downwards plus this 800 newtons downwards, okay? And I know that my net force is 0, so essentially then the force downwards and the force upwards have to be equal. So all I have to do is add these two together, and that will be my force upwards. Agreed? If they're going to add up to 0, the applied force has to be equal to the sum of the two downward forces. So all I do is go 800 plus 8,517, and I get 9,317 newtons as my force applied upward. Okay. The net force is 0, right? Okay, so the net force is 0. That means that FA plus these two forces is 0. Okay, so that means whatever the force downward is, that's what the force upward is in the opposite direction. Okay, so as long as I can find these two forces and add them together, which I already did, right? This one's F parallel, that's the force of friction, right? So if I add them together, that's the total force downwards. The total force upwards has to be equal to that. It would only be 3 significant figures, yes. Yeah, because I used the 10 degrees to calculate F parallel. So 9,000 or 9.31 times 10 to the 3, or 9.32, sorry, times 10 to the 3. 4 on the other one. Okay. So any other questions on that one? Okay. 9,000 or 9.31, 9.32, sorry, times 10 to the 3. Okay. Should only have 3 significant figures. Okay.